Hello everyone, welcome to Max Penny. Today we are discussing system of linear equations. Here we have a system of linear equations. We have a11x1 plus a12x2 plus etc. a1 and xn equal to b1 etc. an1x1 plus etc. annxn is equal to bn. That means we have n unknowns x1, x2 etc. xn and the coefficients a11, a12, etc., ann, and b1, b2, etc., bn also there. This system we can represent it as it is in matrix form. That means the coefficient a11, a12, a1n, etc., an1, etc., ann. If the coefficient put it in a matrix and the unknowns x1, x2, etc., xn, which gives a column matrix, and the bi's b1, b2, etc., bn, which is also a column matrix. That is, I represent this matrix as capital A. This is an n by n matrix here. Here, this is my system. So, this is an n by n matrix. Since there are this much of coefficients, so this is n by n matrix. And this unknown matrix, this is n rows and one column. N by 1 matrix, that is capital X. I am denoting it as capital X. This is n by 1 matrix. And this is b1, b2, etc. bn. I am denoting it by capital B. This is also a column matrix n by 1. So basically the system is Ax is equal to B. This is representing the system of this linear equation. And the system of linear equation Ax equal to B. So Ax equal to B either has solution. Ax equal to B is my system of linear equation. I am representing it as the matrix form. So either solution exists or it has solution or solution does not exist. Solution does not exist. Either the system has a solution or it has no solution. And solution exists means it has a solution. Solution does not exist means it does not have a solution. No solution condition. So solution exists if it has solution. We say that the system is consistent. So if a system has solution, then it is consistent. And the other case is inconsistent. That means if a system of equation has a solution, then it is consistent system and otherwise it is inconsistent. So consistent means solution exists. Solution exists means we have two cases. Either it has unique solution, that means only one solution, or it has many solutions, that means infinite solution. This is the two possibilities. This is only two possibilities. That means if the system is consistent, it has unique solution. Either it has unique solution or it has infinite solution. It is inconsistent means no solution. System has no solution. And the condition for the system using the rank of the matrix, we can denote this matrix A. This is the coefficient matrix A, and together with the column matrix B, the last column would be the matrix B, that is B1, B2, etc. Bn. And then this matrix is called augmented matrix. Augmented matrix. So for solving this system using Gauss-Jordan method, we use the augmented matrix to reduce. So considering the augmented matrix and the matrix, coefficient matrix A, if system is consistent means rank of A equal to rank of augmented matrix AB. I separate it with a slash A and the last column is B. So if rank of A equal to rank of augmented matrix, then the system is consistent. So inconsistent means rank of A not equal to rank of augmented matrix. Then system is inconsistent. So rank of A equal to rank of augmented matrix. For unique solution, rank of A equal to rank of augmented matrix and which is equal to the number of variables. Number of variables. In this case, I am using n variables, so this is equal to n. So rank of A equal to rank of augmented matrix means system is consistent. So system has either unique solution or infinite number of solution. If it is equal to the number of variables n, then it is unique solution. And rank of A equal to rank of augmented matrix and which is less than n, which is less than the number of variables n, then it has infinite number of solutions. So consistent means rank of A equal to rank of augmented matrix. Inconsistent means does not equal to rank of augmented matrix. And which is equal to n number of variables, then it has unique solution. And which is less than n, that means number of less than the number of variables, then it has infinite number of solutions. So this is basically the system of linear equation and its consistency, inconsistency, and its unique solution condition is this and infinite solution condition is this. So let's solve an example. Consider the system x plus 2y plus 3z is equal to 4, 2x plus y equal to 2, and x plus 5y plus 8z equal to 10. Consider this system. Now let's solve this system. First of all, we represent this system in matrix form as the coefficient matrix A. First column contains the coefficients of x, that means 1, 2, 1. And second column is for y, 2, 1, 5. Third column is for z, 3. And no z there, so 0, 8. And the unknowns are x, y, z. And the B matrix is 4, 2, 10. The augmented matrix here is the augmented matrix A, B is 1, 2, 3, 2, 1, 0, 1, 5, 8. This is A matrix. And the last column is the B matrix 4, 2, 10. So this is the augmented matrix. Either you can separate it with a line or this is enough. Now we are using Gauss-Jordan method. Gauss-Jordan method means we can reduce this matrix to RREF, row reduced echelon form, so that we get a solution, or we can simply use Gauss elimination method. That means simply reduce the matrix to REF, row echelon form, and solve the system. So just using elimination, we can solve. That means REF is enough to solve this. And Gauss-Jordan method is for RREF. That means RREF is easy to calculate the solution or determine the solution. So either we use REF or we can use RREF. So I'm just reducing the matrix to find a solution. So first of all, I want to make this element 0 and this element 0. So first operation is for R2 minus 2, 2 R1, and for R3 minus R1 is enough. So R1 has now changed 1, 2, 3, 4, and R2 is 0, 1 minus 2 R1, 1 minus 4 minus 3, 0, minus 6, 2 minus 8, minus 6. Now R3 minus R1, 0, 3, 5, 6. Now let's make this element 1 so that it is easy to compute. So R2 changes to R2 into minus 1 by 3. So I'm changing R2 to 0, 1, 2, 2, 0, 3, 5, 6. Now let's make 3 to 0. That means I'm using the operation R3 gives R3 minus 3 R2. So R1 has no change. R2 is this. R3 is 0 minus 0. 3 minus 3 is 0. 5 minus 6 minus 1. 6 minus 6, 0. So this is in REF. This is enough to determine the solution. For more precise, you can use or you can reduce this augmented matrix to RREF. And just using this matrix, I'm solving this system as matrix. What we get? This is for x, this is for y, this is for z. That means 1x plus 2y plus 3z equal to 4. Next, 0x. 0x means 0 plus 1y plus 2z equal to 2. Next, 0x 0y minus z is equal to 0. That means z is equal to 0 is clear. Z is 0, that means which implies y equal to 2. Z is 0. So y is equal to 2. Now, using this equation, x plus 2 into y is 2. So 2 into 2 plus z is 0. 3 into 0 equal to 4. So that x is equal to 4 minus 4, 0. So x is 0. My solution is, that is my matrix capital X is 0, y is 2, z is 0. 0, 2, 0. This is my solution. You can see that I get only one solution. That means unique solution. Let's see the rank. This is my augmented matrix AB. Rank of this matrix is rank of augmented matrix AB is rank is the number of non-zero rows in reduced form. So 1, 2, 3. So rank of AB is 3. And then what is rank of A? So this is A matrix, removing the last column. So this is our A matrix. So this is reduced form of A matrix. Then number of non-zero rows is 1, 2, 3. So rank of A is equal to rank of augmented matrix AB. And both are equal to number of unknowns 3. So rank of A equal to rank of AB means system is consistent. It has a solution. And it is equal to the number of variables 3 means it has unique solution. So this system has unique solution. System is consistent and system has unique solution. Now let's see another example. So consider this system. What is our augmented matrix? Augmented matrix AB is coefficient matrix 1, -4, 2, and 1, 1, 2, -2, and 1, -1. There is no set, so 0. And the B matrix -2, -3, 4. So this is augmented matrix. So in order to find the solution or see the system is consistent or inconsistent, we use augmented matrix and we reduce the augmented matrix. So I want to make this 0 and this 0. So R1 has no change. R2 changes to R2 minus R1 and R3 changes to R3 minus R1. This is 0. 2 minus -4, that is 6. -2 minus 2, that is -4. -3 minus -2, that is -3 plus 2 -1. Now this is 0. -1 plus 4 is 3. -2, this is 6. Now we can make this 3 is 0 by using the operation R3 gives R3 into 2. That means 2 R3 minus R2. That will make this 3 0. So R1 has no change. R2 also no change. R3 changes to 2 R3 minus R2. This is 0. This is 2 into 3, 6 minus 6, 0. This is -2, -4, -4, -4 plus 4, that is 0. This is 6 into 2, 12, minus -1, 12 plus 1, 13. So this is the system. So this is reduced form of augmented matrix. Now we can see that the rank of augmented matrix. What is the rank of augmented matrix? It is the number of non-zero rows. 1, 2, 3. So rank of augmented matrix is 3. And what is rank of A? Rank of A. Rank of A means rank of this matrix. Removing the last column. Reduced form of A has 2 non-zero rows. The last row is 0. 2 non-zero rows. So rank of A is 2. So we can say that this is not equal to this. Rank of B not equal to rank of A. So which implies the system is inconsistent. Inconsistent means system has no solution. No solution. The system has no solution. Suppose we got a system and this is the RREF of that system. So that means the augmented matrix of a given system reduces to this form. This is in RREF since the pivot element. This is pivot element and pivot column contains only the pivot element non-zero. Other elements are 0 though. So this matrix is in RREF. Suppose this is a system and its RREF is this. Suppose we have a system of equation and the reduced to augmented matrix has this form, RREF. So we can solve the system. First of all, we have 1, 2, 3, 4. 4 variables and this is the equal part of the matrix, augmented matrix B. So we have 4 variables and using x1, x2, x3, x4 to denote the variables. So 1 x1, x1 plus 0 x2 plus 1 x3 plus 1 x4 equal to 3. And second row gives 1 x2 plus 0 x3 2 x4 equal to 1. and third row gives nothing, which is 0. So this is x1 is equal to 3 minus x3 minus x4. Here x2 is equal to 1 minus 2x4. This is 0x3. This is 0x2. So x1 equal to this and x2 equal to this. You can see that here pivots are in first column and second column. No other pivot element. Pivot element means leading element. First non-zero element. So this is a pivot element. In first column, we have a pivot element. Second column, we have a pivot element. No pivot element for third column. So this is corresponding to x1. This is corresponding to x2. So x1 and x2 is visible. So here this is for x3 and this is for x4. x3 and x4 are free variables. Free variables means we can choose any values to x3 and x4. We get corresponding x1 and x2. That means if I put x3 equal to 0 here and x4 equal to 1, x3 equal to 0 and x4 equal to 1. So I get x1 is equal to 3 minus 0 minus 1. 3 minus 1, 2. And x2 equal to 1 minus 2 into 1 minus 1. So corresponding to each values of x3 and x4, I get x1 and x2. So x3 and x4 are free variables. We can choose any values to x3 and x4. For putting values for x3 and different values for x3 and x4, I got x1 and x2, different x1 and x2, corresponding x1 and x2. So this system has infinitely many solutions. Infinitely many solutions. Since x3, there are two free variables, x3 and x4. So infinitely many solutions. Let's check the rank of augmented matrix. What is rank of augmented matrix? This is in reduced form. So rank of this matrix is 1, 2. Last row is 0. So only two non-zero rows. What is rank of A? Rank of A means removing the last column. Consider the other part. This is reduced form of A matrix. So number of non-zero row is again 2. So this is equal. Rank of AB and rank of A equal. And this is equal to 2. What is number of variables? 4. Number of variable is 4. That means this is less than 4. So rank of AB equal to rank of A means system is consistent. System has a solution, but the rank is less than the number of variables. That means system has infinite solutions. What are the solutions? You can write it as x1. Solution is x1, x2, x3, x4. What is x1? x1 is not a free variable and x2 is not a free variable. So x1 is 3 minus x3 minus x4. x2 in terms of x4, 1 minus 2 x4. Since x3 and x4 are free variables, we can write x2 and x1 in terms of x3 and x4. So x3 is free, x4 is free. Now I can write it in x3, we have minus 1 first row. Second row no x3, third row 1 x3, last row no x3 and plus x4. I'm writing this as a combination of x3 and x4. x4 is minus 1 in first row, second row minus 2, third row 0, last row 1 and the remaining terms is 3, 1, 0, 0. So this is the solution x1, x2, x3, x4 and if you put different values for x3 and x4, we get different solution. That means we have infinite number of solution. This is the solution of this system. So I am not giving a system here. I am using an RREF of the system, augmented matrix of the system. So this solution is for the system. So it has infinite number of solutions. I hope this is helpful. I hope this is clear for you. If you want any more examples or if you have any doubt, please put it in the comment box.